bright future. Every student matters.
Hello learners, welcome to your lesson on symmetry. This is the last lesson with which we are going to complete the lesson of symmetry. This lesson is about, by the end of this lesson, you will be able to know something about the paper decorations that we can do using these reflection and symmetry. Then you will be able to know what kaleidoscope is, and then you will also know what is the application of reflection symmetry. Right, so starting with the reflection and symmetry itself, let us understand what do we mean by reflection and symmetry. So when you stand in front of a mirror, what you see in the mirror is your reflection. Okay. Similarly, if any object is placed in front of a mirror, what you see in the mirror is called its reflection. Line of symmetry and mirror reflection are naturally related and linked to each other. Why? Here is a picture that you can see here in these two images. In the first one that you see the letter M, it is kept in front of the mirror. So what you see in the mirror is its image, and you can see the mirror is exactly the same as you see if you draw M as a symmetrical figure by the line of a symmetry, right? So clearly here the picture which is shown to you, the reflection of English letter M, you can imagine that the mirror is invisible and can be just imagine that M as this here. This is the line of symmetry and this is the image that is observed. So what you see, it's exactly the same, but it is opposite to what is the object itself. Now, if you see the object and the image, what you will notice about them is that they are symmetrical, right? And with they are symmetrical to what? With the reference of the line of symmetry. And if we are talking about mirror, it is basically the mirror line which is making it symmetrical. As you can just see in this image, here the child is playing with this particular structures. So these blocks he has kept in such a way, and the image that he is observing in the mirror, it is exactly the same he is seeing on the other side as well. So other thing that you can see where you can observe such kind of images is that if a paper is folded, the mirror line becomes the line of symmetry. We can say that the image of the reflection of object is the mirror line. You can also see that when an object is reflected, there is no change in length and angle. Everything still remains the same, right? Now, look at this question, it's very interesting. It says, if you are 100 centimeters in front of a mirror, where does your image appear to be? If you move towards the mirror, how does your image move? So if suppose this is the mirror, and when you are drawing a mirror, you just draw such slanted lines in order to show which side you will have the reflection. Okay, so this is the object. Say this is a person who's standing in front of the mirror. And the distance of this particular person from the mirror is 100 centimeters. Okay, so this is the distance between the object and the mirror. Now, we'll see its reflection on the other side of the mirror. Is that right? So here comes the reflection of this person. Now, what distance we'll see is, we will notice that this particular image is exactly 100 centimeters away in the mirror itself. So what do we notice? We notice that if an object is kept at a certain distance from the mirror, its reflection, its image will be exactly the same distance away from the mirror. Okay. Now if this person starts to move towards the mirror, okay, say it moved to 20 centimeters towards the mirror. So now you will notice that this particular image has also moved 20 centimeters towards the mirror. I hope this is clear. And say if this particular image moves 60 centimeters towards the mirror, then you will notice that the image itself has moved 60 centimeters towards the mirror. I hope this makes sense. Now let us move to the next question. It says some examples of reflection and symmetry. Here you can see the images of paper decoration. This is one of the favorite art that I used to do when I was in school. What you do here is, you just take any piece of paper and you make several folds of it. So keep it folding like horizontally, then vertically, then again horizontally. Just keep on making several folds of it, and then from the corner make some cutouts. like you can see here. And when you open the paper again, you will see these beautiful patterns on the paper. It is saying that we can use a rectangular sheet of paper, fold and create some intricate patterns or by cutting the paper. Okay, so you can make such interesting patterns. Try it yourself. It's really fun to do this. Moving ahead to kaleidoscope. What is a kaleidoscope? This is again a very fun activity that you can do at your home. A kaleidoscope where you use a mirror to produce images that have several lines of symmetry. Usually we use two mirror strips forming a V shape, as you can see here in the image. So here we can see this is mirror 1 and here we have got another, let me just write it, mirror 2. Here we have got two mirrors that we have attached, and one of this particular side of this particular the triangular face that we have made, we keep a black paper over there. Okay, we don't put any mirror over here. Now the angle between the mirrors determine the number of lines of symmetry that will make. So how much small or how much big your kaleidoscope is, it will make the difference in the patterns. Okay, so if you see from one of the end by putting a certain object on the other side, you will see some beautiful patterns like this, and you can use different objects to observe this. You can use different broken pieces of bangles. You can have beautiful like a glitters that you can keep in front of it, and if you just see them through the kaleidoscope, keep on moving the kaleidoscope and you will see these beautiful structures being formed. Okay, so it's again an activity. If you want, you can must try this particular activity. Moving ahead, let us read about application of reflectional symmetry. Here it says this is a particular situation that is given to us. A paper delivery boy wants to park his cycle at some point P on the street and delivers the newspapers to house A and B. Where should he park the cycle so that he walks distance AP plus BP will be least? So what we are given here, he needs to travel to a certain point. He's going to park his cycle over here at point P, and he needs to park it somewhere so that house A and house B, he needs to travel the minimum distance. Okay, now what we will do, let us use the method of reflection to see where he can park his cycle, right? So you can use the reflectional symmetry here. Let A dash, here we have put a point A dash, be the image of A, that is the house that we have, right? Then the point P is the ideal place to park the cycle. You can see here this point P. This is the exact place where he should park his cycle. This particular street that we see, we are keeping this as the line of symmetry here. Now where the mirror line and A dash B meet. So where do you see A dash B are meeting? This point P. This is the line of symmetry. Can you say why? Why do you think this is the best point? Clearly, if you see that this particular point P, if you are measuring the lines, you can see how much distance is between A dash P and PB. So this is how he can make sure that he is traveling the minimum distance between the two houses, that is A and B, so that if he does AP plus PB, or because A and P is giving you the same distance as A dash P and PB, if this gives you the least measure, that would be the best position for him to locate his cycle. Okay. Moving ahead to some Rangoli patterns. Now, columns and Rangoli are popular in our country. In Diwali, in Holi, in several festivals, you must have seen that how people draw these beautiful patterns in front of their houses. In fact, in their houses, right? So this is a very beautiful pattern, very popular in our country. A few samples are given to you. Look at these images that are in front of you. Can you see that there are certain line of symmetries are there in this pattern? We just don't draw random figures when we are looking at rangolis or columns. We see that they are drawn by using certain dots. You see this is a column. And here we have certain dots that we draw, and then using those dots, we draw certain lines that are joining these dots, and a beautiful pattern is seen. And every time, if you notice, you will see the line of symmetries in them. Look at the first one here. This is the line of symmetry. This is the line of symmetry. Here, this. In such a small figure, we can clearly see 4 lines of symmetries. Is that right? Now look at the next one here. We can have 1 line of symmetry here, 1 line of symmetry here, another one that is vertically, horizontally. We can see another 4 lines of symmetry. Similarly, look at this particular 1, 2, then 3, then 4, 5, 6 lines of symmetry are possible for this particular figure. Now this one here is a beautiful example of a Rangoli. Now this is a very heavy pattern, and if you try to make the lines of symmetry, there will be many lines of symmetry, right? So I'm just trying to draw a few. So it's 1, 2, 3, 4, 5, and you can draw many. So it is possible that in as much complicated Rangoli that you see, that many number of lines of symmetries are possible in them.